Hey, what's going on, guys? Mr. Flores here. Alright, and this video is going to be dealing with factoring quadratics where a is equal to 1. Okay? When we... So I don't like you were just kicked out. When we talk about quadratics, again, we're talking about the equation in the form ax squared plus bx plus c. Okay? And when I say a is equal to 1, that means that the leading coefficient here is equal to 1. Alright? It's going to make your life easier when you factor. Factoring is one of those things that's very, very important in math. Every math class you're in, you're going to need to be able to factor. You're going to need to know how to factor. You get to pre-calc, calculus, if you take advanced trig, anything like that. Factoring is very, very important because it's assumed that A, you already know it, and in order to do deeper and higher level of thinking in mathematics, you need to know how to factor. So if you can't factor, you're going to be at a disadvantage, okay? Before we factor, we're going to go over something that we all know, and for this problem, we have 3x times the quantity x plus 7. Okay, we all know that you must distribute this 3x into our parentheses. So 3x times x gives us 3x squared. 3x times 7 gives us 21x. Okay, so basically we went from this top expression down to the bottom expression by distributing. Okay. Factoring is the opposite method. We're going to go from this bottom figure to the top figure. Okay, that's factoring. Okay, so really, factoring is just one of the ways that we can rewrite a mathematical expression or equation to help us out in finding something. Okay, and specifically, it's for solving quadratics or really any polynomial. Okay, but we'll get to that in later on videos. So really what we're doing is we're just going to be undoing distributing, or when we get to binomials, undoing a FOIL. Okay, but again, I'll go over that all over again. All right, so basically, when you have a binomial, okay, or it's just two pieces like this, we want to get back to the 3x times x plus 7. Okay, so if you have two pieces, you need to find the GCF. Okay, GCF. It's very, very important, at least with a binomial or it's two pieces. Two terms, I should say. So the GCF is the greatest common factor. So we need to find the greatest common factor between 3x squared plus 21x. Well, between 3 and 21, the GCF is going to be a 3. Okay. The GCF between x squared and x is just x. Since it's two x's here, since it's x times by itself, so they at least have one in common. If we factor out of 3x, we're left with just x. We factor out of 3x from 21x, we're left with just 7, which if you notice is what we started with originally, okay? Because factoring is undoing the distributive property. It's undoing multiplication of polynomials in a way, okay? So, but if you notice, if it's a binomial, you want to find the GCF and factor it out. The next example is this buddy here, okay? And everyone loves this because it's FOIL, or basically we're just going to multiply x minus 2 times x minus 3. Right. The one thing kids always forget is that you must multiply the x in the first set of parentheses by both terms in the second parenthesis. Likewise, you have to take the negative 2 and also multiply it by both parts in the second parenthesis. So when we multiply this, we get x times x gives us x squared. X times negative 3 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. When we combine like terms, we get x squared minus 5x plus 6. Okay, and again, this route from our answer to the purple is called FOIL, or really it's just multiplication or distributing, whatever you want to call it. Then to go from the x squared minus 5x plus 6 back to this, that is called factoring. Okay, that's what we're going to be doing today. And again, it gets tricky, but there's just a common theme that you're always going to follow, okay? Because the last term, which is C, we need to find something that deals with this, and then our middle term, which is B. But again, that's only if A is 1, okay? And I'll explain. So basically, we want to factor by getting from the standard form back to factored form, okay? And the trick here is you need to find two numbers that multiply to the C, so two numbers that multiply to 6 that also add up to negative 5. Okay? And since you already have this problem, we know that the two numbers that are multiplied to negative 6 positive 6 and add to negative 5 are going to be negative 2 and negative 3. Okay, so negative 2 times negative 3 is positive 6. Negative 2 plus negative 3 is negative 5. So you know that works because that's what we need to get. So your answer would be x minus 2, x minus 3, which coincidentally is what we started with. Okay, the reason why this whole little like shortcut works is that this c term is always the multiplication of the minus this second number and this second number. Okay, then this middle term is just the addition of this number and this number with an x added on to it. So if this is our question, x squared minus 5x plus 6, the factored form is, well, x minus 2 times x minus 3. So really you're just undoing the FOIL. Okay, so we'll do some examples. Hopefully it gets a little clearer. So you have 12x squared minus 24x. Again, this is a binomial. There's two pieces. So for this one, we just want to pull out the GCF. We want to know what's the greatest common factor. Well, when we look at 12 and 24, we know that they have a common factor of 4, they have a common factor of 6, they have a common factor of 12. Again, the GCF is the greatest common factor. So for our instance, we want 12 because it's the greatest. Then this is x to the second, x to the first, so they both at least have x to the first. Okay, so we factor it out. Technically you can divide. So what's 12 divided by 12 is 1. X squared divided by x is just x, minus negative 24 divided by 12 is 2. X divided by x is 1. So your final answer is 12x times x minus 2. If you were to distribute this 12x back into parentheses, you would end up at your answer, because we did factoring to simplify it, okay? It's just another way of rewriting this to help us out. All right, so the difference between this problem and this one is that it's a trinomial. There's 3 pieces. If there's 2 pieces, just factor out a GCF. If there's 3 pieces, this is when you need what times what equals the last number, then what plus what equals the middle number. Okay, so you need to find 2 numbers that multiply to 3, add to 4. Well, luckily the only numbers that multiply to 3 are 3 and 1, and coincidentally 3 plus 1 is going to give us 4. So the answer is x plus 3, x plus 1. Okay, this is the standard form, this is factored form. Okay, we're just changing the way it looks to make it easier for doing certain things we want to do. All right, ooh, this should be a squared. Okay, so we have x squared minus 3x minus 10. All right, again, it's a trinomial, so we need 2 numbers that multiply to negative 10. Those same 2 numbers have to add to negative 3. All right, so we go and we think the factors of 10 are going to be 10 and 1, 5 and 2. Well, we notice that since it's a negative 10, one of these have to be negative, and they need to add to a negative 3. So I'm going to say negative 5, positive 2, negative 5, positive 2. Satisfies our requirements, so it's x minus 5, x plus 2. And we're done. Again, x squared minus 3x minus 10 is the same exact thing as x minus 5 times x plus 2. It's just a different way of writing it to make it work for us in a different way. And as we get farther in the year and as you get farther in mathematics, you'll see why we want to know the different way to write it. Okay, but again, that's really all factoring is. It's just changing the way something looks to help us out. All right, so you look here and we have 3x squared minus 27x plus 60. You're going to say, hey, Mr. Flores, you told us this is only when the a, or the leading coefficient, is a 1. Okay, and that's true. I did tell you that. But if we notice, we can pull out a GCF between 3, negative 27, and 60. Well, that GCF is a 3. So when you factor out a 3, you get x squared minus 9x plus 20. Okay, now it's a trinomial with a coefficient of 1, so we need to find 2 numbers that multiply to 20 that also add to negative 9. So let's look at it. 20 is 20 and 1, 5 and 4, 2 and 10. All right, well, let's try 5 and 4 since we know they can equal 9. So if we do 5 and 4, it satisfies the top requirement, but they have to add to a negative 9. So if we make them both negative, it's true. Negative 5 times negative 4 is 20. Negative 5 plus negative 4 is negative 9. All right. So when you write your final answer, okay, it's going to be x minus 5 times x minus 4. Okay. But if you remember, we pulled out the 3 in the beginning, so you still must also write the 3 at the end. Okay. Because we can't change the expression at all. We just need to make it look differently. So since it was 3 times this whole quantity, it's still 3 times x minus 5 times x minus 4. That's your final answer. All right. I hope you're getting the hang of this. Guys, the first step, always pull out a GCF. If you notice, this problem, there's no GCF. This problem, no GCF. This problem, we pulled out the GCF. Okay. So again, we have 2x squared plus 4x minus 16. All right. So the GCF, I'm going to say, is a 2. So it becomes x squared plus 2x minus 8. Again, we need two numbers that multiply to the last, which is negative 8. The same two numbers must add to the middle, which is positive 2. All right. So the factors of 8 are 8 and 1, 4 and 2. All right. We need the numbers to be equal to, I'm going to say 4 and 2, since that's the only way we're going to get 2. So it's going to be 4, 2, 4 and 2. We want it to be a positive 2, so we have to make the 2 negative. So 4 times negative 2 is negative 8, works. 4 plus negative 2 is positive 2, works. So our final answer, again, is going to be 2, since we factored out the 2 in the beginning. X plus 4, x minus 2. Okay? And we'll do one last one. Okay? But before we do that, a question a lot of kids ask is, does it matter which way I write these? And the answer is no. So 2 times x minus 2, x plus 4, these are the equivalent. These are exactly the same. They're both okay. Because multiplication is commutative, so order doesn't matter. So if you do the x plus 4 first, or the x plus 2 second, both these are perfectly fine. All right, last one. We have x squared plus 7x minus 10. So we need two numbers that multiply to negative 10. The same two numbers must add to 7. Let's check it out. So 10, we have 10 and 1, 5 and 2. All right. Well, since we know it's going to be a 7, we must use 5 and 2. All right. So 5 times 2 is not negative 10, but 5 plus 2 is 7. Well, we have to make one of these negative, so let's try the 5. Negative 5 times 2 is negative 10, but negative 5 plus 2 isn't 7. So let's negate the 2. That works. 5 times negative 2 is negative 10, but 5 plus a negative 2 is not 7. Okay. So if you notice, there's actually no combination that's going to make this correct. Okay. So what we're going to do for now is we're just going to call it prime. Okay. Because right now we only know the basic factoring method. We don't know any of the fancy formulas or other things we can do. So right now, if you can't find two numbers that multiply to the last and add to the middle, you're just going to call it prime. Later down the road, we're going to find out how you can do it using the quadratic formula or completing the square. All right. But for now, just bear with me and know that it's prime because we can't find anything that multiplies to the last and adds to the middle. All right. Again, guys, I hope you found this video useful. Factoring is one of those things that it just takes practice, practice. But I promise you, it's going to help you out this year. It's going to help you out next year. If you plan to go to college for any type of mathematical background thing, whether it's physics, chemistry, bio, math, even some business degrees, you have to take a lot of math. Factoring is one of those things that never goes away. It just makes your life easier. All right. So work on some of the worksheets below the video. If you have any questions, you can send me an email. Let me know. Hopefully this video worked. Hopefully you learned something from it, and have a good one. All right, it's not stopping.